Algebra 1, Lesson 76. We are multiplying radical expressions. We will also be looking at Lesson 77, where we are solving our inequalities. Now these are more multi-step inequalities. So first of all, with multiplying radicals, we have this product property of radicals that we have been using in order to simplify our radicals, but we also can use it backwards. So if we have root a times root b, we can combine them to be the square root of a times b. So for example, if we have the square root of 8 times the square root of 2, well, we could rewrite that as the square root of 16. We could say, well, yeah, we can combine those and say that that's the square root of 16, which is just 4. So many times we are multiplying these radicals so that we can then simplify them even better than what we have. Okay, some other examples here. If we have 6 root 2 times 4 root 3, well, we can multiply the radicals together, and we should multiply the coefficients together. Meaning that I need to multiply 6 and 4, those are what I can multiply together to get 24, and I can multiply together root 2 and root 3 to get root 6, which actually can't be simplified any further. Next, 6 root 3, all of that squared, technically what that means that we're doing is we are taking 6 root 3 times 6 root 3. So we can multiply the 6's to get 36, multiply the 3's to get the square root of 9, which is just 36 times 3. Okay, so we would get, let's see, 108, something like that, 108, if I'm doing that right in my head. All right, so other ones that we can try, root 50 times root 2, well, that's just the square root of 100, which is just 10. 3 root 2 times 5 root 7, we can multiply the 3 and the 5 to get 15, and multiply the root 2 and root 7 to get root 14. And that square root of 14 can't be simplified any further. 4 root 6 squared, well, if we think about this, just like we did on the last page, the 4 is going to be multiplied together, so we get 16, and the square root of 6 multiplied together, well, that's just the square root of 36, which is just times 6. Which I believe we get 96. So think about how if we have the square root being squared, that means that we're going to have offsetting operations, and they're going to end up canceling each other out. We can add variables to it, like in this last one, so that we can say we have 3 root 12x squared. Now we can simplify the 12x squared by saying, well, that's 3 times root 4 times 3, and then times x, which means the x's end up coming outside, and the 4 we can simplify to just 2. So we have 3 times 2 times x times root 3, which is just 6x root 3. Okay, other examples here. We can distribute with our root signs, which means I can take this root 2 and multiply it by 3 and by that root 6 to get 3 root 2 plus the square root of 12, which can be simplified to 3 root 2 plus, well, that's 12 is 2 times 2 times 3, so I can pop out those 2's and get 2 root 3. Unfortunately, these are not like radicals, so we can't combine them together. Root 2 and root 3 cannot combine. Okay, next one. I want to make sure I can do anything, I want to make sure and simplify as much as possible. So inside of the parentheses, and I can actually rewrite this as root 2 times root 6 minus, well, that's square root of 9 is just 3. So I can expand and get the square root of 12, which is 2 root 3 minus 3 root 2. Always put your coefficients before the radicals just so that it does not get confused to be part of your radical. All right, keep expanding here, and we get 8 root 3 plus the square root of 18, which is just 3 root 2. Think about the square root of 18 can be the square root of 9 times the square root of 2, so we get 3 root 2. And lastly, okay, we get the square root of 24 minus the square root of 15. Square root of 15 can't be simplified, but the square root of 24 can, to 2 root 6 minus square root of 15. And none of those are like terms, so we can't combine them together. Now, another thing that we can do here is multiply binomials with radicals. Now, the first one here actually ends up being that we can simplify it and expand rather than going through the entire area model or FOIL or rainbows and smiley faces, because 4 plus root 9 is really just 4 plus 3, or 7 times the quantity 2 minus root 6, which means that I get 14 minus 7 root 6. But the second one, we do need to go through the entire thing, so I'm going to show the area model. Remember, in the area model, we are multiplying everything out. So we have 3 and a positive root 2, 6 and a negative root 5. And so we get 18, 6 root 2, negative 3 root 5, and since these are both radicals, we multiply them together and get a negative root 10. All of these are actually in simplest form already, and none of them are like radicals, so we just put them all in a line. 18 plus 6 root 2 minus root 10. And that is actually our simplified version. All right, and lastly with lesson 76 here, remember that when we have 6 minus root 3 squared, that technically means that we're doing 6 minus root 3 times 6 minus root 3. So we need to go through our box method or rainbows and smiley faces, which I'll do here. So we get 36 and minus 6 root 3. We get another negative 6 root 3 and a positive root 9, which is just plus 3. So altogether we can combine the 36 and 3 to get 39 minus 12 root 3. Okay, you can do it on your own, but do realize that you can simplify the square root of 8. And lastly, just know that we can use these radical expressions to figure out areas of rugs or carpets or rooms, even if they have radical expressions as their lengths. We just need to multiply together 8 plus root 5 and 2 root 2. So we would do our box method or FOIL or something like that. All right, so lesson 77, we are looking at our inequalities one more time. And now we're going to make sure that we know how to do these when there's multiple steps involved. So for example, if I have 8m minus 12 is less than negative 36, I am going to work this through just like when we work through 2, 3, 4 step equations. The only thing I really need to remember is if we have to divide or multiply by a negative number, I have to switch the sign. Now my goal is to get my variable alone on the left side of my inequality. So I, in this case, would add 12 because I'm doing PEMDAS backwards, and I get 8m is less than negative 24. And then I divide by 8 and get m is less than negative 3. So I put it on my number line, and since it's a less than sign, I put an open dot, and I go to the left showing those smaller numbers. All right, I'll just do one of these. I'll do the top one here. And if I have a 9 minus 3m is greater than 21, I'm going to get rid of that 9 first by subtracting it. And I get a negative 3m is greater than 12. And I divide by a negative 3. Now a little light bulb should go off saying, oh no, we divided by a negative number, so I need to switch the sign. So a greater than sign becomes a less than sign. And we get m is less than negative 4. So it's going to be an open dot on negative 4 going to the left. Okay, I'll just do a couple of these to show when they get a bit more complex. Really doesn't change anything. We continue doing what we normally do. Combine those like terms on each side and start working away at your variable. So I'm adding 12 to get negative 7 is less than negative 7d. And I'm going to divide by negative 7. And once again, light bulb should be going off because I'm going to switch my sign. And I get 1 is greater than d. Now, I have d alone. I've made sure to flip my sign when I have negatives, but now I need my variable on the left side, which means I'm going to completely move around everything that I have. So d and 1 are on opposite sides, which means I also need to flip the sign. Okay, so it's going to become a less than sign. D is less than 1. Same process is going to go for that bottom question. Just make sure you expand correctly. And I'll just do one more with the fraction one on the bottom here. So I'm trying to get y by itself, and I'm going to subtract 1/2 here. Now I need common denominator, so this 1/2 is really like subtracting a 5/10, which means on the right side I end up with 2/10, or 1/5, is greater than 3/4 y. Now to get rid of a 3/4, I can divide by 3/4 or multiply by the reciprocal. Those are the same thing. So I'm going to multiply this 1/5 by 4/3. And I get y is less than 4/15. Alright? And we can use word problems in these situations. Just solve them like you normally would here, and so that we can solve our different situations. Okay, and here's one more example of that as well. Set up your own inequality so that you can figure out how many months is it going to take him to collect enough stamps. Well, I hope this is helpful for your homework and for studying.